The Jacobs Institute is really designed to collaborate with industry and physicians to drive innovation. We need industry to provide better tools for us to continue to what we do, which is develop tools for physicians to train and test in different clinical environments.
In an ideal world, if you wanted to practice a procedure before you actually do it on a patient, you want to replicate every element of that procedure. You want to know how that tissue is going to feel as you're delivering a device. You want to understand how all the different gadgets that you're going to use for the procedure, how will they behave in that particular anatomy.
Anatomical models that I've been seeing since I was in medical school, they really did not have any semblance of reality in terms of their behavior when you utilize them. We would rehearse device deployment, usually in silicone models with some fluid, some water, some glycerol, and it was grossly unsatisfactory.
About 5 years ago, we started working with Stratasys on what is 3D printing doing in medicine, and the JI and our partners here in Buffalo truly believe that it's the future of medicine.
My first exposure to 3D printing, it was a real sort of eye-opening experience where 3D printing, well, you print what you need for the particular task that you have, where we can now incorporate plaque within arteries and thicker walls versus thinner walls, and with fluids, make it feel real.
One of the questions we've repeatedly heard from our customers, both medical device customers as well as hospitals, is the need for biomechanical accuracy. The biomechanical accuracy that the digital anatomy printer provides is really what's differentiating this solution from anything that's on the market today.
In terms of digital anatomy printing materials, there's now gel matrix, there's tissue matrix, and there's bone matrix. They all can be used, different mechanical properties, depending on what you're trying to accomplish. So the software is a really huge part of where this is all going. GrabCAD Print now allows us to really select and drop down menus certain materials on a point-by-point voxel-based approach.
GrabCAD Print really revolutionizes how we design medical models today for anatomical modeling. So instead of going in and saying, I want a white femur bone, we can go in and select a femur for a 70-year-old. If you want a femur for a 20-year-old, we can do that. We can vary the density of our structures on our bones.
We're having third parties validate the biomechanical properties of the materials that come with the digital anatomy printer. So the Jacobs Institute, companies like Medtronic, they are conducting third-party testing to compare how those materials compare biomechanically to native tissue, to native bone, to specific anatomies and pathologies that you'd expect to see in practice.
So now we're using digital anatomy of areas and applications we've never done before. And these are things that you have to pierce, you have to cut the model. We weren't able to do that before.
The long-term goal of the digital anatomy printer is to replace the need for cadavers, to replace the need for animal studies, where it gives our customers the option of having specific anatomies and specific pathologies that are not currently accommodated by either cadavers today or animal studies. The digital anatomy solution today is only the beginning. Every year for the next 3 to 5 years, we will come out with additional materials, additional applications and software solutions that increase the capabilities of the digital anatomy printer.
The Stratasys partnership in terms of the JI mission is absolutely paramount. We would not be able to accomplish our mission without partnerships like Stratasys.